Most people think getting good at math is about intelligence. It isn't. It's about how long you're willing to stay inside confusion without escaping it. Because math isn't a subject you memorize, it's a system your brain has to adapt to. And the biggest difference between average students and top performers across many Asian education systems isn't discipline, it's tolerance. A trained tolerance for slow understanding. Here's the part no one tells you. In many high-performing math cultures, students are not trying to get it quickly. They expect not to get it, at least not at first. And that expectation changes everything. Because when your brain expects difficulty, it doesn't panic when confusion shows up. It leans in. Think about how most people study math. They read a concept, they see an example, then they try a problem. If they can't solve it within a few minutes, they check the solution, they move on, and their brain quietly learns something dangerous. Struggle means stop, but the real shift happens when you reverse that rule. In many Asian classrooms, there's a concept often described as productive struggle. Students are given problems that are intentionally slightly beyond their current ability, and instead of being rescued quickly, they sit with it, sometimes for 10 minutes, sometimes for 30, not passively staring, but actively testing ideas, breaking the problem apart, trying something that might fail, then trying again. What looks inefficient on the surface is actually building something deeper. Cognitive endurance. Because here's what math really is. Pattern recognition under uncertainty. And you can't build that by watching solutions. You build it by failing through patterns until your brain starts predicting them. So the Asian secret isn't a secret technique. It's a different relationship with difficulty. Let's break it into a system you can actually use. Step 1. Delay the solution. When you get stuck, don't check the answer immediately. Set a timer, 10 to 15 minutes minimum. Your only goal during this time is not to solve the problem. It's to explore it, rewrite it, simplify it. Ask, what do I already know that touches this? Even if you make no progress, something important is happening. Your brain is mapping the edges of the problem. That map is what makes the solution meaningful later. Step 2. Study the failure, not just the answer. When you finally look at the solution, don't just say, "Oh, that makes sense." That's a trap. Instead, compare, where did your thinking diverge? At what exact step did your brain choose a different path? That's the moment you learn. Because math improvement doesn't come from seeing correct solutions. It comes from understanding incorrect instincts. Step 3. Rebuild without looking. Close the solution. Now try the same problem again, from memory. Most people skip this, but this is where the real wiring happens. Because now your brain isn't just recognizing the solution, it's reconstructing it. And reconstruction is what builds retention. Step 4. Compress the pattern. After solving, ask one question. What type of problem is this? Not the topic, the pattern. Is it a substitution pattern? A symmetry trick? A hidden constraint? Give it a label in your own words. Because experts don't see problems, they see categories. And the faster you can categorize, the faster you can solve. Step 5. Repeat with variation. Do 3 to 5 similar problems immediately. Not tomorrow, not later. Now. Because your brain is in a temporary high adaptation state. Miss that window and you reset. Use it and you compound. This system looks slower, but it's not. It just moves the time from the end to the middle. Instead of rushing through 20 shallow problems, you go deep on 5. And actually change how your brain processes math. And there's one more layer most people ignore. Silence. In many high-performing study environments, there's less constant stimulation. No switching tabs. No background noise fighting for attention. Just you and the problem. Because deep mathematical thinking requires uninterrupted cognitive loops. Break the loop, and you reset the process. So, if you want to study math effectively, stop asking, how can I understand this faster? Start asking, how long can I stay with this before I give up? Because the students who get good at math aren't the ones who avoid confusion. They're the ones who outlast it. And once your brain learns that confusion is not a signal to stop, but a signal that you're close, everything changes. Not instantly, but permanently.